Hello, Dan Perry here, and welcome to TCP/IP Basics Part 7. In this video, we're going to continue our introduction to IP version 4 addresses. So we're going to continue examining the addresses. We're going to learn about classful addressing in this video. Now, classful addressing was developed back in the 80s when IP version 4 was being developed as a way of grouping IP addresses at a time when it was thought that IP addresses were very plentiful, or going to remain very plentiful. Classful addressing divides your IP addresses into 5 groups or classes. These classes were used to decide or to assign different size address spaces, different numbers, in other words, of IP addresses to different groups and organizations. It was a very inefficient use of IP addresses. However, at the time it was being developed, with the look of the internet or the goals of the internet at that time, it was thought to be more than adequate. They did not expect that basically everybody on the planet would be connected to the internet. It was really still being looked at for businesses and for universities. Class A addresses have a value, a decimal value in that first octet of 0 to 127. The Class A addresses essentially use the first octet for the network and the other 3 octets for addresses or machines on the network. Now, I said 0 to 127. 0 and 127 aren't usable values in those octets for reasons we'll get into later. So we really have 1 to 126. That gives us, since the first octet is used for the network portion and the other 3 octets are 24 bits for the host, that gives us 2 to the 24th, or 16,777,216 addresses per network. It was originally given to very large organizations and used by those. Even the largest companies did not need address spaces that size. Today, many of those Class A ranges have been assigned either to entire countries in some cases, or here in the United States to large internet service providers. The Class B address has a value in the first octet of 128 to 191, and it splits where the first half, or first 16 bits of the address, are part of the network, and the last 16 bits are part of the host or the machine addresses. This gives us 2 to the 16th, or 65,536 possible addresses. And this was originally given to medium-sized organizations. Today, still a lot of companies have Class B addresses, but more and more those are being given now to smaller and medium-sized ISPs. The Class C address, which is the smallest class that's used for public addresses, or addresses that computers use typically on the internet, has a value in the first octet of 192 to 223. The first 24 bits are used for the network, leaving only 8 bits for the host or the machine addresses, giving us 256 IP addresses per each network. And these were assigned to small organizations, small companies. Sometimes a little larger company may be given 2 or 3 or 4 blocks of these. The school I teach at has 8 blocks of the Class C addresses, giving us 2,048 possible addresses. We currently have probably in the neighborhood of about 1,700 computers, printers, and other devices on our network total. Class D networks, the first octet range is 224 to 239, and those are reserved for multicasting, for being able to send out one packet to be received by multiple computers. We'll talk more about multicasting later. And the Class E, the last group with a first octet value of 240 to 255, is something you probably will never see. And that range is used for research and testing purposes. With the IP addresses, we do essentially divide those addresses into two parts. The first part is what we call the network portion, and it identifies the network that a host or a machine is on. The host portion, it identifies a particular computer on that network. So we've got a network portion that it identifies the network, host portion, the computer. The network portion is always the leftmost part of the address and the host the rightmost. The number of bits in the host portion will determine how many devices you could possibly have on your network. Okay. And in our next video, we're going to continue looking at TCP IP addresses and how we actually start using them in our network.